Hi, good morning everyone. Today I would like to share with you the lecture 12, Laplace transform properties. Okay, now let's look at the first properties, that is the linearity. Okay, if you look at this one, Laplace transform of the x1t, you will get x1s, which is the time s domain. Okay, and the ROC is the R1. For the Laplace transform of x2, you will get the x2s. Okay, with ROC is R2. So for a constant of C1 and C2, the Laplace transform of the C1 x1t C plus C2 x2t. So you have to, for linearity, Laplace transform of C1 x1 plus C2 x2, you will get C1, that one is a constant, and the Laplace transform of the x1t, and then plus with the C2, and then C2 is a constant, Laplace transform of the x2t, and then the ROC is the intersect region of the R1 and the R2. Now let's look at the example of the linearity. Example, let the xt equal to 3 delta t minus 2 exponent t, and then find the Laplace transform of the xt. Okay, so the xt is given like this. So from the Laplace transform table, you know that the delta t is equal to 1. Okay, and then exponent t, you get 1 over s minus 1. So this is from the Laplace transform pair tables. So Laplace transform of the xt, you will get Laplace transform of the 3 delta t minus 2 exponent t. So 3 delta t, delta is 1, so 3 times 1, you get 3. And then 2 times with 1 over s minus 1, so you get 2 over s minus 1. So you multiply in, you get 3s minus 1 minus 2 over s minus 1. So this is the denominator, okay? And then you simplify it, you get 3s minus 3 minus 2, so 3s minus 5 divided by s minus 1. So this is the answer for the Laplace transform of the xt. Okay, let's look at another example. Using the linearity property, prove the Laplace transform of the sine bt. Okay, sine actually you can change to the exponential form. Okay, you still remember the sine is the Euler, using the Euler formula. So in the exponential form, sine you can sine bt, you can have the exponential j bt minus exponential minus j bt divided by 2j. So this is for the sine. So for the Laplace transform of this sine, okay, you will get using the definition, using the formula. So it's from 0 to infinity, and then this is the sine, and then exponent minus st dt. Okay, so you just you take out the 2j because this one is like a constant. Okay, you multiply in, so exponent j bt, you will multiply with the exponent minus st, so you get exponent minus s plus bj in the bracket t dt. Okay, similarly to this one. And then this is the integration. You perform the integration. Okay, so 1 over 2j, perform the exponential, the integration to the exponential. You will get 1 over minus s plus jb, and then exponent minus s plus bjt. And then you will get the condition, the limit is from 0 to infinity. Okay, similarly to this, the later part, that one is the same. Okay, 1 over 2j, the bracket 1 over minus s minus jb. So for the integration part. Similarly, the limit is still from 0 to infinity. Okay, and then for the case s more than 0, okay, s more than 0, you substitute the value of 0 and infinity. Okay, here you get negative infinity. Okay, maybe you ask why you get negative infinity instead of the positive infinity. Okay, if you look at here, negative s plus bj. If you take out the negative here, so you will get negative in the bracket s minus bj, and then close bracket t, right? So you have the negative here. So actually is you have to take out the negative. So it's a negative in the bracket, open bracket s minus bj and close bracket t. So if the t is substitute with the infinity, so you have the minus infinity. That's why you get the minus infinity here. So exponent minus infinity, you will get 0. Okay, exponent 0, you will get 1. Okay, similarly to the behind part, okay, the later part. So once you substitute, you get the 0 minus 1. So you 0 minus 1 is so -1. Multiply with here. Okay, multiply here. Multiply to the first part. So you will get the positive here. So you get S. Okay, just now you said negative, right? Negative in the bracket S minus JB. So negative multiply with negative, you get positive. So you get 1 over S minus JB multiply with 2J. So similar to here, you have the negative here, multiply with the negative here, you get positive. So 1 over S plus JB. Okay. And then you want to identical the denominator. So because you cannot have the operator here, right? So you have to identical the operator. So S minus JB multiply with S plus JB. Okay. So same to here. Each one you have to multiply, and then you simplify. So S plus JB minus S minus JB. So this one S minus S you get 0. So plus JB plus JB. JB plus JB you get 2JB. Okay, 2JB over S minus JB, S plus JB. Okay, so the J you can cancel out. Okay, just left the B here. Okay, 2J you can cancel. Just left the B at the numerator. And then for the denominator, you multiply in. So S minus JB, S plus JB, you multiply, you get S square minus J square B square. Okay, so J square is equivalent to the -1. So -1 multiply with the minus, you get positive. So that's why you get B over S square plus B square when the real number S is more than 0. Now let's look at the example 3. Xt equal to x1t minus x2t. So Laplace transform of the x1t is 1 over s plus 1, in which the s is more than -1. And Laplace transform of the x2t is 1 over s plus 1, s plus 2, in which the s is more than -1. So you need to find, the question asks you to find the xs and then plot the ROC for the x1, x2, and xs. Okay, so from the question, we know that the xt is x1 minus x2. So x1 is given the x1s is equal to 1 over x plus 1. And then x2s is 1 over s plus 1, s plus 2. So you just perform the operation here, minus operation. So you multiply in, be here, you need another x plus 2. So you multiply s plus 2. You get s plus 2 minus 1. So you simplify, you get 1 over s plus 2. And then what about the ROC? The question asks you to plot the ROC for the x1, right? ROC for the x1, if you look at the x1 is 1 over x plus 1. 1 over x plus 1. So the s is equal to -1. The ROC should be include the ROC property 1 is include the j omega x's. So and then the real is more than -1. So you plot the x1 is -1, right? So it's more than, you sketch it. And then for the x2, what is the answer? S is more than -1. S is more than -1. Okay, you plot the x2 is s equal to 1, x equal to -1, x equal to -2. So you have the two pole value, that is -1 and -2. But you still remember the properties of the Laplace transform said that it cannot include the pole value. So for the right hand side, you cannot include the pole value. That should be more than -1. Okay, so in fact is given the ROC for the x2 is more than -1. You just sketch it only. And then for ROC of the xs, okay, xs is what's the answer? Is 1 over s plus 2, means the s is equal to -2 to the right hand side. So ROC must include the j omega x's, so it's at the right hand side. So more than -2. Now, second property, time shifting. Okay, let's xt be the function, and the t naught is a shift in time, in which the t naught is more than 0. So Laplace transform of xt minus t naught and ut minus t naught. So this is the shifting, okay, for the t minus t naught. Both the xt and the ut has a minus t naught. So the integration from 0 to infinity, xt minus t naught, ut minus t naught, and exponent negative st dt. So now let's look at how the time shifting properties or the formula form. Okay, so you have the xt is like this, and this is the formula for the Laplace transform. So you multiply with the exponent negative st dt. So the t is from the limit is from the t naught to the infinity, xt minus t naught exponent minus st dt. And we assume the tau is equal to t minus t naught. Therefore, if you want to get the t here, so it's tau plus t naught, okay? And then dt change to d tau. So now you have Laplace transform of the xt minus t naught, ut minus t naught, right? So change to t minus t naught, you change to the tau, right? So x tau. And then same to here, exponent negative st. So t change to tau plus t naught. So tau plus t naught d tau. Okay, I'll change in the form of tau. So exponent negative st naught is the constant. Okay, it's a constant because we want to do is in the tau. So remain the 0 to infinity x tau exponent minus s tau d tau. Okay, so this part which assume it as a xs. Okay, so that's why when the time shifting property, you see this is the formula in order for the to do the time shifting properties. Okay, let's look at the time shifting properties for the rectangular bows. Okay, using the shift and linear properties, find the Laplace transform of the rectangular bows if the xt is equal to ut minus t tau. Ut minus t naught. Okay, we know that from the Laplace transform table, ut is equal to 1 over s, and ut minus t naught, and just you get it is exponent minus st naught over s. So for the ut minus t naught, you will get 1 minus s minus exponent minus st naught over s. Okay, and then you just okay, simplify, you get s minus exponent minus st naught, and 1 minus exponent minus st naught. We go to another example. Find the Laplace transform of the xt equal to 5 ut minus 2. Okay, as we know the time shifting property, you get the x minus t naught, you get exponent minus st naught xs. So ut is 1 over s. Ut is 1 over s. So so the 5 ut minus 2. Okay, so Laplace transform of the xt is xs 5 exponent minus 2s. Okay, because of the t naught is 2. T naught is 2, so exponent minus 2s xs. So xs is referred to the ut. So ut is 1 over s. So you have 5 exponent minus 2s over s. Okay, another example, find the Laplace transform of the xt equal to the rectangular t over 2. So first of all, you need to know rectangular t over 2 is which unit step. Okay, t over 2, rectangular t over 2 is from minus 1 to 1. Okay, from minus 1 to 1. From the basic knowledge of the rectangular signal, you know that t over 2 is from minus 1 to 1 with the amplitude is 1. Okay, so if you write in terms of unit step, that one is the ut plus 1 minus ut minus 1. So Laplace transform of the xt is Laplace transform of ut plus 1 minus ut minus 1. Okay, for ut plus 1, as same as the previous example, you have the t naught is -1. So exponent -1. This is the t naught, okay, divided by s. Similarly, this one, the t naught is 1. So exponent minus s over s. So your answer is exponent s minus exponent minus s over s. That's all for the time shifting and the linearity properties. Thank you.